Hello and good morning. Let's take a look at today's bell work. So, we're finishing up week 5. The date is right here. So this is going to be, let me think about this, 11, 12, and this is week 5, quarter 2. Make sure you mark that down. All right, let's take a look. First of all, draw a triangle and then draw the perpendicular bisectors. Well, bisector means it cuts it in half in 90 degrees, cuts it in half in 90 degrees. And where they hit is called the circumcenter. And the significance of that, and you need to know this for the test, is the distance from that point to the vertices are all equal. So if this one is 5, they're all 5. And that is called the circumcenter, and it uses the perpendicular bisector. The next one, draw a triangle, the angle bisector, cut the angles in half, and where they hit is called the incenter. This is called a point of concurrency where they hit. All right, so the significance of the incenter is the distance to the sides are the same. And this one forms a circle inscribed. This one forms a circle circumscribed. And this is your radius. So if you want the diameter, you would double it and get 10. All right, so let's go on. This one right here, draw a median, draw a triangle. A median is a midpoint of the sides, and then you connect it to the vertices. And where they hit, it's called a centroid. Okay? And the significance of the centroid is, if they give you the whole thing of, say, 15, you would divide by 3, and you would get 5. So the little piece would be 5, and the bigger piece would be 10. 10 plus 5 gives you the whole thing of 15. That's a centroid. A centroid is a balancing point if you were going to balance that triangle. And then finally an altitude. An altitude is straight down. So the highest point, straight down. You turn your triangle to where this is the ground, and the highest point straight down is the altitude. And where they hit is called the Ortho-center. Okay? And those are the 4 that you need to know. All right, let's move on. We already talked about the implications. You do have a test this weekend. If you need a hard copy, it's going to be Monday. If you're not here Monday, it'll be Tuesday. Make sure you're ready. Also, your homework for week 5 is due this weekend. If you turned in work into the box, it'll be checked sometime today. All right, let's talk about the practice test. So in geometry, if you want to make an A, master this practice test. So we're going to work it right now. So here we go. This one right here, what you have is ray DF, and you need to read it correctly. Ray DF bisects FDG. So this is a ray that cuts the angle in half. So these are equal. The distances from any point are equal. So you're going to say n plus 3 is equal to this one. You're going to subtract n, and you're going to get 3 is equal to n minus 3, and then you're going to add 3, and you're going to get 6. So n is equal to 6 when you add 3. Now, the question is, find FG. FG is this one. It's the same as this one. So I'm just going to say 6 plus 3 is 9, and 9 should be the answer, and it is. Okay? So an angle bisector, the distances to the sides are equal. If the distances to the sides are equal, then it's an angle bisector. Let's go to the next one. Two paths of a garden are shown by ray DF and DG. DE rather. So this is a path DE, and this is a path DG, okay, to a garden. A new tree is planted at location F. So here's your tree. All right, the question is, which statement about point F is true? The tree is nearer DE. Well, DE, let's see, than DG. So DE is here, and DG is here, and the tree is nearer the path. No, the tree is equal. Those distances are equal. The tree is nearer the path B, shown by DG, than DE. No, they're equal. The tree is equidistant. Yes, that's the answer. Okay? It's the same distance. All right, number 3. Where is the circumcenter of any given triangle? Okay? So, where is it? Well, the circumcenter of any given triangle, circumcenter is the perpendicular bisector. So the answer is the perpendicular bisector of the sides. And there it is. All right, let's go to number 4. Where can the perpendicular bisectors of the sides of a right triangle intersect? Well, draw a right triangle. And then go in the middle, make it 90 degrees. Go in the middle and make it 90 degrees. If it's a right angle, it's on the triangle. So this one is on the triangle. Only that one. Okay? If it's an obtuse triangle, I think it's outside. All right, let's move on. We've got through 4 of these. Let's keep working. Number 5. Which diagram shows point P equidistant to A, B, and C? Well, look here. The perpendicular bisector gives you that distance where these are equal to A, B, and C. So you want to go with the perpendicular bisector. This one looks like the angle bisector, and the distance to the sides are equal. So you got to know these 3 conditions here. We went over that with the bell work. Let's go here. Find the circumcenter. You have to be pretty accurate here, okay? So you're going to go over 4, up 4, and you're going to call that one point E. Then you're going to go 4 and 0, and you're going to call that one point L. And then you're going to go over 6, 4, 5, 6, and 0. It's right here. So this is a right triangle. And they want you to find the circumcenter. The circumcenter is the perpendicular bisector, so you want to go in the middle and you want to go across. So right here where they hit is that point there. So it looks like 0, 1, 2, 3, 4. It looks like over 5, up 2. So I'm going with 5 and 2, and that's the answer. Okay, remember, the circumcenter is the perpendicular bisector. Let's go to this one. Where can the bisectors of an angle of an obtuse triangle intersect? So draw an obtuse triangle, which is bigger than 90. And then the bisectors of an angle. So draw an angle bisector. And where do they hit? It looks like they're going to hit in the inside. So the inside only is the answer. All right, let's go to number 8. What's the name of the segment inside the large triangle? This is an angle bisector. It splits the angle in half. Okay, angle bisector. Number 9. For a triangle, list the names of the points of concurrency. Perpendicular bisector is the circumcenter. So put circumcenter. Angle bisector, that is the incenter. Median, median is the centroid, and altitudes is the orthocenter. Make sure you write that down. All right, number 10. Where can the medians of a triangle intersect? So let's see, draw a midpoint, okay, and connect it. Draw a midpoint, connect it. This is going to give you your centroid. Let's see what they say. Inside the triangle, on the triangle, outside the triangle. You have to really draw all three of them. So this is an acute. You would have to draw a right triangle, and you'd have to do a median, a midpoint, and another midpoint. And then you'd have to do an obtuse triangle. So it looks like these are all in the inside. So midpoint, midpoint. Okay, so this is only in the inside. Okay, so again, if they want to know where it's at, you have to try all three possibilities. All right, let's go on to number 11. It says in triangle ACE, G is the centroid. So this is the centroid. And BE is the whole thing. So they're giving you the whole thing. So you want to divide by 3, and you get 7. So the little one is 7, and then double that is 14. And so there's your answers, 7 and 14. All right, let's keep moving. Let me make this a little bit bigger. Okay, on this one right here, where can the lines containing the altitudes of an obtuse triangle intersect? So draw an obtuse triangle. Draw an altitude straight down. That's an altitude. And then turn it to where this is the ground, and then draw an altitude straight down to the ground. And where they hit on this one is outside. So this one should be outside. Outside the triangle only. All right, this one right here, triangle ABC has those vertices. Find the orthocenter. All right, so you're going to have to graph it pretty nicely here. So over 4, up 8, point A, over 7, 4, 5, 6, 7, up 8. And then over 4, up 2. Okay, so draw the triangle. Looks like a right triangle. Okay, so they want to know the orthocenter. So what you want to do is find your altitudes. So turn it to where this is the ground and go straight down. It hits here. Turn it where this is the ground and then go straight down. It hits here. That is your orthocenter. So you got to figure out where that's at. So it's over 4, up 1, 2, 3, 4, 5, 6, 7, 8. I would say 4 and 8 on that one right there, and that is the answer. Okay? So just take your time and do a pretty good graph. Number 15, what is the orthocenter of the triangle with 2 altitudes given by the line y or x equals -1? So you have that, x equals -1. So this one drops straight down, and this one drops straight down, and the orthocenter is where they hit, right here. So that looks like -1 up 0. That one actually is pretty easy because they pretty much gave it to you. This one right here, name the smallest angle. Well, remember, opposite the smallest side. So this is the smallest side, and so angle C would be the smallest. Notice it says not drawn to scale. Okay, that means that 7 looks bigger than some of these, but you can't go by the picture. So angle C is the smallest. That's actually pretty easy. All right, let's keep moving. Which labeled angle has the greatest measure? Well, let's see here. Let me think. The diagram is not to scale. Okay, so angle 3 is an exterior angle. And the exterior angle is equal to this one plus this one. So if it takes these two to equal that one, angle 3 is the biggest. Exterior angle. Number 18, let's see what's going on here. They found themselves far apart and they stopped for lunch while working in a field. J could see K, then turned around 52 degrees, and then this one turned around 55 degrees, and this one turned around. Which one's the furthest apart? This one right here, I may have to give you a +1. You can try that one. You might need a protractor on that. All right, let's go to this one. Which angle appears to be the smallest in this triangle? Well, the smallest angle is opposite the smallest side. So 8 is the smallest side, so I would say angle D on this one. And that's what the answer is, angle D. Now let's keep moving, we're almost done. Number 20, which sides could be a triangle? Remember, two sides have to be bigger than the third side. So let's take a look at that and see what's going on here. Okay, so if you add these two up, you get 30, it's bigger than that. If you add these two up, you get 36 is bigger than that. You add this up, and you get 18, and 18 is not bigger than 24. So I would not go with that one. Okay? That one I don't think works. Let's go to the answer here. This plus this is 25 is bigger than that. This plus this is 39 is bigger than that. And this is bigger than that. So that is the answer right there. All right, so let's keep moving. All right, so 21. Two sides of a triangle have those lengths. So 8 and 16, and you're looking for the third one. So to get the third one, you got to add these up. Remember, add and subtract. So when you add that up, you get 24. And when you subtract those, 16 minus 8 is 8. So it can be 9 all the way up to 23. It can't be 8, and it can't be that one. So let's see what it says. It has to be greater than 8, but less than 24. I'm going to go with this one, and that's the answer. All right, let's go to this one right here. Two sides of a triangle are given. It's the same thing. Add it up, you get 27. Subtract it, you get 7, and there's your answer. Those are pretty easy. Let's finish this up. 23. Which sides cannot be a triangle? Let's see. This is 17, and 17 is not bigger than this one, so we'll just go right to the answer on that one, just to save some time. Which of the following must be true? All right, let's think about this. This is the hinge theorem. You have two sides equal to two sides. This angle is bigger, so this side is bigger than this side. All right, so FH is bigger. So FH is bigger than AC. FH is greater than AC. This is the one you want to go with. What happens as the triangle goes from obtuse to acute? Let's think about this. As this angle here decreases, gets smaller, then the side decreases. Okay? So the measure of angle A and the length of side B both decrease. The angle decreases and the side gets smaller. All right, we're almost done. This is the last one, or almost. What is the range of possible outcomes? All right, so look here. This side of this triangle is equal to this side, plus you have reflexive. So you have two sides equal to two sides. Now, this side is bigger, so 46 has to be bigger than 2x. And when you divide by 2, you get x is less than 23. So less than 23 is what you want. So it's going to be, the answer they have is between 0 and 23. Okay, it's got to be bigger than 0, but less than 23. Okay, so you would write that like this. It can't be 0, it can't be 23. All right, what's the possible range? Same thing here. This one is exactly the same problem. So watch what I do. These two sides are equal to those two sides. 18 is bigger. So 10x is going to be bigger than 6x plus 20, and then you're going to work that out. Subtract 6x, and you get 4x. And then divide, you get x is greater than 5. So x has to be greater than 5 on this one here. Now let's see what's going on here. They have between 5 and 18. All right. So it can't be bigger than 18. All right. So it's between 5 and the side 18. So it can't be 5, can't be 18. There it is. That's how you do your practice test. Let's move on now. If you want to make an A, make sure you rework those. All right, let's turn our attention now to MCR. Remember, homework is due. This is week 5, so put 11-12 right here. Week 5, quarter 2, and then work these out. Well, we're going to do group factoring today. You're going to have a little small worksheet. So on this one right here, notice that this has an A, this has an A, this has an A, but this one doesn't. What we're going to do is group these together, and it looks like they have a 3. Like this one is 3 times 4, and this one is 3 times 3. So I'm going to take out a 3, and they also have 2 A's in common. So I'm left with a 4A here, and I'm left with a 3 here. And so here, we already have the 4A minus 3. You can't take anything out of this one. But there it is. See, that's the same as that. So now I'm going to take one of those out, and then I'm left with 3A squared plus 1 when you take the whole thing out. And there's the answer for that. And that's called group factoring. Let's do one more here. This one right here, I'm going to take out an x, and I'm going to take out a 5, because this one is 5 times 7. So I'm going to be left with 7y minus 1. This is a negative, so you have to take a negative. 7 times 8 is 56. So I'm going to take out that 8. So it's going to be that, and I'm left with 7y. It should be the same thing, minus 1. Okay, negative times a negative is a positive. Take this out, 7y minus 1, and you're left with your answer, which is 5x minus 8 times this one. And that's how you do group factoring. So today you have 1 through 10, and then you can relax. So I want the front side of this worksheet, and we'll call it a day. All right, good luck. Make sure you turn your homework in. Bye for now.